Hello everybody. So we've got David back with us. Yesterday's talk was more business oriented. Today we've got a more technical talk from him. So thank you, David.
Good morning. So today I'm going to talk about how you can augment SQL with mostly Redis, actually. I gave this talk at PyCon Russia and PyCon Taiwan recently, and I think it went pretty well. I've kind of talked here in the past about scaling web applications and stuff, and kind of a little bit similar of a topic. But anyways, if you don't know who I am, I'm the author of Sentry. It's an open source tool that logs errors based on yesterday. I assume everybody here uses it. I'm also formerly the infrastructure lead at Discuss. I was there for about 3 years. And then previously, as of last week, I was working for a small company called 10xer. I'm now doing my own thing for the next couple weeks at least. So what do we mean by scale? Well, this is like, I like talking about this a lot because I think there's this misconception in scale. Like every kind of application has scale unless, I don't know, maybe it's a blog and then maybe you hit Hacker News and now it has scale. But so we have some very different kinds of things that I want to talk about today. Like Discuss is like a traditional like huge website scale. Sentry isn't that big yet, but it does get a lot of inbound data, and that data is very expensive to process. And then 10xer, we had a lot of stats, and kind of in a similar fashion as Sentry, we'd have a lot of inbound data, and we'd have to figure out how to process that in an efficient manner. So does one size fit all? A bunch of the solutions I'm going to talk about today can kind of work for any various problem. Generally, like most solutions are very similar in my experience. So I'd like to say most of the things I'm talking about here today you can use in any size application. So the NoSQL movement. There's also the new SQL movement, which I'm not too familiar with. We're not going to talk about any NoSQL today. We're going to talk about caches and denormalizing data. And most importantly, I'm going to talk about why SQL is the best technology choice for storing your data. So Discuss runs on Postgres. It's also Cassandra, Redis, Memcache, any number of technologies, but the foundation is Postgres. 10xer was built on MySQL, works just fine still today. And Sentry actually runs on just about any SQL platform, albeit you'll get different trade-offs. MySQL generally does not perform as well as Postgres today, but the key thing here is that it's very versatile and you can use SQL for just about everything. And the way we do that is by compromising. Like Discuss, which is larger than most applications, has absolutely no issue running on SQL. Like you can plan ahead for capacity, you can work things out, and it's a known system. And so the biggest thing we want is predictability. Like your scale is all about like how predictably you can deal with this problem when you grow from 1 to 1,000 users. And as I said, like the main focus of this talk is going to be how we can augment that SQL. We've chosen SQL as our backend, and we're going to stick to it. So what can we do to better make that scale? Lots of technologies. My favorite is definitely Redis. It's the most simplistic data store that I'm aware of that actually is very, very useful. But different problem sets have different solutions. We tried a number of them at Discuss. Most of them don't work. React and Cassandra are a couple of my other favorites. HBase is a very popular one. And all of these are more like operationally easy. Because technically you could take a SQL database and you could scale it out to as far as you need to. So Redis is kind of my favorite tool for the job. We use it for any number of things, but generally we treat it as a cache, but we treat it as a cache that's expected to have the data in it versus Memcache, which we don't really care about. And so the first thing I want to talk about are counters. So counters kind of exist everywhere. They take many, many shapes and forms, but literally every number on a website, you could think of as a counter. We have a leaderboard. It's just full of counters. They may be structured differently, but they're still simple counters. Discuss has an obvious one. It's like how many likes do you have or something like that. Just a counter of how many likes you have. Sentry, maybe even more obvious. It has counters all over the place. I assume everybody's familiar with how to write SQL. update the table, set the counter equals the counter plus 1. It's an atomic operation, transaction safe, all is well. Redis, very similar, just an anchor command. An important thing to know about Redis is it's single-threaded, so everything is atomic as long as you send it in one batch. And the one main reason that I'm going to show this in Redis and not Memcache is because the key does not need to exist, which is the most useful feature of counters ever. And it's one of my biggest annoyances with Memcache. And this is actually pretty important because if you just want to anchor a counter that may or may not exist, like in Memcache you have two network operations no matter what. Redis you have a single operation. So counters in Sentry, and this is kind of interesting. This was like a clever hack that we came up with, and it's worked. So we have a bunch of events that come in. Some of them are the same. We got 2 of the same over here. We got 2 other different ones, and they all anchor a Redis key. And we just call these buffers in Sentry, and it's kind of abstracted a little bit. But the idea is that when we have these 2 events coming in, they increment this one key, and then eventually that one update gets flushed to the database. So we're just delaying what we're doing, and it allows us to safely handle the throughput that's coming in with the database because the database is going to have contention writing that row over and over, and this more or less eliminates it. I talked a little bit about how that works. The important thing is it all goes through the queue, and we actually explicitly say in 10 seconds, increment that key. Like whatever your problem set is, it's kind of up to you. How many of you are familiar with statsd? It's used by Graphite and a number of other things. It's kind of similar. We do this on the server. statsd sort of does it on the client. So it makes it like distributed, but you're still getting a batch of writes coming in every so often. So the clever hack for this is actually every time those come in, we fire a task using Celery, and what it does is an atomic operation with a pipeline. It gets and sets the value to 0. So it says get counter for event number 1, set the value to 0, write that to the database, and then if any other job comes in for the next like 10 seconds, it's gonna basically have seen this as like a lock and saying, oh, somebody already did this, I can just no op and return right away. And again, the big important thing is here that we get one SQL update for every single unique event for whatever our delay period is. So there are actually some negatives here. The biggest thing is if you see like the Sentry task graph, when a bunch of events come in, it gets through them really fast, but then it expands like this in new tasks. So you get a lot of these no-op tasks. But like it makes it very, very easy to do everything with. With Redis, we can just add more nodes, and because we're using this as a very realistic cache, it doesn't really matter. We don't have to like migrate data or anything. We just drop them in and start routing requests to them, and it's very easy to implement. So we actually were thinking about this, and we haven't implemented it yet, but we were trying to come up with an alternative way to do these counters to try to get rid of those no-op tasks, and there's some potential other caveats. So another solution would be to take all of these, throw them into a sorted set, a single key, and a sorted set in Redis basically contains a key. In our case, it's going to be the event ID, and it contains a score value. And in this case, like our score value is just going to be the number of times we've seen it. So now we have a bunch of those coming in where we're anchoring an event, like this event, this event, this event, and we end up with a list like this. You can kind of think of it as a dictionary. And basically it looks very similar to our previous pattern. In this case, like instead of firing tasks, we're going to have a periodic task through Celery schedule or something, and we're going to say every X 5 seconds we need to flush all of those updates. And we can still fan out the same way we did before. It's not just like one single worker has to process all this data. It just needs to flush it and then pipe those into other jobs. So use a command called zrange to get this, and then the idea here is that you zrange and you get, say, these 100 events are pending. Fire off jobs for those, and each of those jobs is actually going to do a single atomic operation that gets the value and it removes the value from the set. And this actually makes it fairly safe, so if like maybe those tasks were lost in transition somehow, or you couldn't keep up with a scheduler, like eventually you're going to get to it and it's still going to just flush out that one key per event. So the big thing is it gets rid of all those no-op tasks. You don't need something complicated like Celery. You just need a cron job to schedule these up. There's sort of one con, and it's actually not a big deal. It's a single Redis key. And you might think about it and you're like, well, a single Redis key, that means I have a single Redis node. But that's actually not true. You could potentially have that same key on every single node, and when you're flushing updates, you would just have to reach out to various nodes and get get more data to go through. The second kind of pattern that I've seen all over the place are activity streams, and these just as common as counters. There's many different forms of this though. It's a little bit less obvious. So just some examples here, but like if you look at Discuss, it's kind of an interesting example because Discuss has the comment widget, which you just see a list of comments. That's just a stream of comments. It can be materialized, and you have your moderation panel, which is just a stream of comments based on some pre-existing conditions. You look at Twitter, you have the same thing. You have your timeline, you have your replies timeline, all this. These are all just different activity streams. So in Sentry, we'll use this as a simple example. Like we just have a SQL table that links us to an event, and it has some arbitrary data about what the event type is here. So in this case, we might be resolving an event, or the event might be going from resolved to unresolved. And we end up representing that like this. We've got a bunch of them bound to events. Doesn't really matter how this works in this case, but the idea is that you've represented what happened in an abstract way. And the important thing to think about here is that this is just a cache. It's also known as a view. And somebody was talking about this yesterday, and I know there's a bunch of Postgres talks, but Postgres 9.3 is finally getting some forms of materialized views. They're still not great. But ideally, this becomes much easier when Postgres better supports it and you don't have to implement a bunch of the code that I'm about to show you. So if you were going to do this in Python, it's kind of obvious. We're going to have a little global list here, and every time we need a new event, we're just going to insert it at the top, and then to get the events, we're going to return a slice of that, right? Obviously, you would never do that in production. How we might represent this is Redis is actually very similar. We're going to use a sorted set again, and this is actually a pretty common pattern, I think. And in this case, for the score, we're actually going to use the timestamp when the event was created, and this means we get them again sorted in time order. So pretty obvious. The one thing is here we use rev range, which is similar to range. It just pulls out a slice of the objects, and in this case, it does it in reverse, so descending order. Adding, I talked about pipelining, very simple. This is actually using something that I wrote at Discuss called Nidus, and it's just an abstraction for Redis, basically. But you basically can call pipelines, and you can basically, within this context right here, you can call as many commands as you want, and that's going to do a multi-exec, more or less. It's going to send them all to the server. They're all going to execute in order, and you're going to get the responses of all those back. Queuing, which is, how many of you actually rely on queuing for your applications every day? Pretty good amount? That's good. So you're ahead of what I thought was the curve. I assume most of you use Celery, or I know there's some Redis options. I don't know if there's any good ones for RabbitMQ, but we always end up using RabbitMQ or Redis for this, and we always end up using Celery. And the nice thing here is, I consider RabbitMQ a production system for queuing.